We have two triangles in this situation, triangle ABC and triangle DEF. We wish to show that we can transform the first triangle, or through a series of transformations, we can map it onto the second one. In doing this, we prove essentially that the triangles are congruent to each other. This is called a series of rigid motions, or congruence transformations, or isometries. When asked to do this, I recommend that you first reflect the object if it's necessary, secondly rotate, and then finally translate it. I find that to be the easiest case. There are a number of ways to do it, and I'll show you a couple or three for this one example. To determine if you need to reflect the object, you need to examine its orientation. So if I were to turn triangle ABC 90 degrees counterclockwise so that this were at the top and this were at the bottom, I'd have a problem because A would be on the left, whereas over here D is on the right, and so it's oriented opposite. And so I know that I need to perform a reflection. Specifically, it has to be a reflection over a line. I can reflect it over any line I want. I'm going to choose the x-axis, and I'm going to reflect this object over this line. Very good. And now we can see that if I were to turn this 90 degrees at this point, it's going to be oriented the same way as triangle DEF. Next I'm going to rotate. I hope you can see that I'll need to move it, I'll need to turn it 1/4 turn or 90 degrees in this direction, counterclockwise. And so that's exactly what I'll do. Rotate this object about this point 90 degrees counterclockwise. Okay, and then we're only one step away, and all we need to do is translate at this point. You don't need to use vectors to translate yourselves, but in GeoGebra, that's how it's done. And I hope you can see that I only need to move this one to the right. To write this translation, I would write something along the lines f of x, y equals x plus 1, y. So I'll write that out. F of xy equals x plus 1, y. So that's where that's the translation that we're performing. If I were asking you to explain the transformation that's taking place, that's what you would need to do. We're going to translate this object by, I never drew a vector. The vector, if I were to write this as a vector, it would just be an arrow that goes one to the right. Okay, and to translate this one to the right, I'm going to translate by that vector, and it takes it. So I've mapped it from here to here through a series of transformations. Again, that series of transformations is reflect over the x-axis, and then rotate 90 degrees counterclockwise about the origin, and then translate according to this translation right here. Okay, now I said there was more than one way to do it, and I probably don't need to convince you, but I will nonetheless. So instead of reflecting over the line y equals x, why not reflect over the line, instead of reflecting over the x-axis, why not reflect over the y-axis? I'm going to reflect this object over this line. And now I need to rotate it 90 degrees, but this time instead of counterclockwise, I need to rotate it 90 degrees clockwise. Rotate this object about this point 90 degrees. This time we're going clockwise. And it takes us to the same spot, our two transformations as the last time. To finish this, I would translate it one to the right. And then finally, if you get a little more creative, you can actually get a lot closer with your reflection, and you won't even need to rotate it, actually. So let's reflect this object about this line. And it takes us right there. We're only one step away at this point. If I ask you to describe a series of transformations, I don't care if it's 3 steps or 2, or if you can do it in 1, that's great. In each situation, you need to show that it can be done through a series of rigid transformations. And again, I recommend reflecting first, then rotating, and finally translating.